Hello, my name is David Arnold, and this is Team 11's preliminary design review for Project 55, Machine Learning for Automated Insect Classification. In this project, we will create two deep learning models that will automatically classify ant species in North American insects based on images. The system will consist of four main components: a deep learning model trained using Google's TensorFlow, a server running backend software to classify images and deliver results, a web-based interface, and Android and iOS applications for mobile devices. These interfaces will allow users to upload images to the server and view results.
Hello, my name is Sadai. I'm going to talk about the design and architecture of our solution. So first, we start off with our data sources. These are web APIs as well as websites that will provide us with information about insects that we can use to train our machine learning model. In order to get this data, we're going to have to write data scrapers, which will retrieve the information, parse it, and store it into our data stores using an internal API. This internal API will also be in charge of storing the data that we retrieve from the external data sources into formats that are more easily consumable by the different components of our system. One of these components is our trainer, which will essentially use this data to train our predictive model using machine learning techniques. This internal API will also be consumed by a public-facing API. This public-facing API will drive public website features as well as mobile app features. One of the reasons for going with this type of design, where we have a public API driving websites as well as the mobile app, is that it can allow us to do things like rate limiting, which will prevent us from being harmed by malicious users. Thank you.
Hi, my name is Aaron Holzman. I'll be discussing our implementation strategy for the project. The system will be broken down into several smaller components. First, the database and the server will be stored on a computer provided by our sponsor. This computer is a shared system and it is located at our sponsor's site, so we will only be accessing it remotely. The server will be responsible for training the learning model using the data stored in the database, receiving image files from the front-end applications and processing them using the learning model, and then returning the results of that process. On the front end, there will be basically three different applications: an iPhone app, an Android app, and a website that all basically have the same functionality. They allow you to establish a connection with the server, upload a picture for analysis, and then display the results after they are returned. Testing will be performed on each module as we go along: the learning models, the server, and the user interfaces. So in addition to the Spectrum, that's the learning model computer provided by our sponsor, we will be using our own computers. They range from Lenovo to HP to Apple, and our cell phones, including both iPhones and Androids, to create and test the system. So in order to accomplish all these tasks, our team needs to perform some independent research. We need to learn and understand TensorFlow, which is an open source software library in Python that was created specifically for the purpose of machine learning. We also need to research machine learning and how that works. According to our schedule, we will be finished with our independent research by October 31st. After that, we hope to have the web crawler finished by November 10th. We need to have a complete data set with augmented images for the ant classification model by December 10th, and then by December 31st, we should have a working ant classification model. By February 7th, we will have a server up and running, and then we will focus on the data set and model for the North American insects as opposed to the ants. The data set will be finished by February 21st and the model by March 7th. And we should have our website finished by March 31st and our iPhone and Android apps by April 21st.
The process our team has elected to follow is a flavor of the Agile method Scrum. The three roles our process has are product owners, which are our project sponsors, the Scrum team members, which is the development team, and the Scrum Master. The Scrum Master is responsible for removing any blocks our development team has. The Scrum Master will be rotated out monthly. Our team will utilize an online Scrum board at taiga.io. The first activity of our process is to populate the product backlog. Here, the product owners will meet with the Scrum team, and we will define user stories which describe the functionality of the system in development. The product backlog will be updated throughout the lifetime of the project. Sprint planning meetings will be held to set the objectives of each sprint. Any user stories which are to be implemented during that sprint will be moved from the product backlog to the sprint backlog. The objective of sprints are to implement all functionalities described in the sprint backlogs. Sprints last 2 weeks. Each week of the sprint will have 3 stand-ups, Monday, Wednesday, and Friday. The point of the stand-ups are to update the team how we're doing and to notify the Scrum Master if there are any blocks. After each sprint, we will have a sprint review. Here, the Scrum team can show off all the accomplishments of the last sprint to the product owners. Lastly, after each sprint, there will be a sprint retrospective. Here, the team can ask ourselves how we're doing as a team, what's working for us, what's not working for us, and how we can get better.
My name is Francisco, and I'm going to be talking about risk management. We were asked to identify 3 different types of risk: technical, communication, infrastructure, and then provide mitigation strategies for those. Our technical risk was going to be lack of experience with machine learning. The mitigation strategy we had is effort, just putting in the effort to learn, time management, and collaboration. For communication, the risk we identified is going to be scheduling conflicts. And the mitigation strategy that we had for that is going to be record meeting minutes for those that may have missed the meeting, and then also thorough communication through Slack. For infrastructure, we identified a couple. We're going to be using third-party websites for most of our workload. We may run into rate limiting issues or site downtime, which would cause us to not be able to get work done. And then also training the ML model is going to be done with resources that have outside owners. So we're going to have to, the mitigation strategy that we had for the infrastructure risks, we're going to do data scraping during low traffic hours, and then we're going to plan ahead, giving ourselves plenty of time to do the data scraping in case we do run into rate limiting or site downtime. And then for the training of the ML model, our sponsors working on access to all the necessary resources. We actually did get confirmation that, or did get access to those resources, and we're working that all out now.